Okay, so now that we've repaired the power supplies and the amplifier board, I went ahead and did a little cosmetic work while I'm waiting for some parts. First up, I pulled the faceplate off and I cleaned and deoxidized and lubricated all my controls and switches with Deoxit D5 and Fader Lube F5 for the controls. And then I went ahead and replaced the lamps because I wanted it to start looking good. Cleaned it all up inside and out, cleaned all the faceplate and the glass and everything. So now we can fire it up. You can see all the lights are working. There's the relay engaging. We can actually do another audio test here. I've got a signal going into my auxiliary input. And I can start cranking up the volume here. You'll see the meters move here. And you can also see on my scope up there, right up there, you can see the two sine waves. Here's balance, so we can go to the left channel only. Right channel, might do that, yep. And there's both. There's volume up and down, so we know that the audio circuit's working, the amplifier board's working. We just have to pop in those IC packs, and we should be producing sound out of the speaker jacks in the back. We also know the preamp's working. You can check the FM. And you see it goes right into stereo. I'm not, I still don't have my dial string done. I'm gonna do that probably at the beginning of a day instead of the end of the day, because I want to end on a good note, and restringing tuners can sometimes go real smoothly and sometimes it can be a little frustrating. So we'll save that for the next video. I've got it tuned to a station here, and you can see I have audio up there on the scope. All right, here's a look at the inside of the KR-9600 on the bottom. So as you see, I've got the amplifier heat sinks taken out along with the TA-200W IC packs, which are defective. They even have a red X on them from the previous technician. And the other side right here. So I've got the boards hooked up to my scope. I've got my bypass resistors in place going from pin 3 to pin 5 and pin 8 to pin 5, and then same thing on this board. Pin 3 is here, 5 and 8. 3, 5, 8. And then we can also make sure our voltages are right, so we can check. Let's fire it up real quick. Relay engages for both relays, so we can check pin 1. We should get our positive rail, and pin 10 should be our negative 64, positive 64. And then on this side we've got negative 63, positive 63. So we're good there. We also want to make sure we have no voltage on pin 5. Should be millivolts. And we're getting 14.5 millivolts on that channel. That's your DC offset, basically. And 23.4 on that channel. So that's good. It says anything less than 0.2 volts is good. And then when you check pin 3 with the resistors in place, you should get about 6.5 or so to 7 volts on that one, and negative 6 on that one. Negative 6 and 6. So that's a good sign that our amp boards are fixed and working. We can also check for audio on the scope. I got a 1 kilohertz sine wave fed into the auxiliary input, and I can crank up my volume and let you take a look at the scope over here. Okay, so there's our sine wave. Both channels working good. Looks like we're in good shape. So next step is to put in the amplifier modules, and what I've got are from Pyramid Audio, the TA-200W Plus, and it's modern transistors, surface mounted resistors here on a PC board, and some mounting hardware. It'll mount basically, and we'll show this part probably. It's going to mount in place over that chip right there, that direction, and then they clamp down, so we've got heat dissipation to the heatsink. So there you have it. We've got one for each channel. Both these chips are shorted, as I mentioned. So the next step is going to be to clean up those heat sinks, remove the old parts, pop in the new IC chips. Got a couple more caps I want to replace on these amp boards. They're on order, so once that happens, then I'll put it all back together. I don't want to solder these connections once because the previous tech already did a little number on them, and I don't want to lose any more of those pads. But yeah, we're coming along. It's up and running. I think in the last part of this video, we got the amplifier boards up and running. We did a audio test just to make sure everything was working before we ordered parts. And in the meantime, I went ahead and rebuilt the protection board with new caps, new relays, and I added a resistor here for the LED swap because it gives a little more current draw, which helps the relay engage properly. And then we recapped the power supply board, a couple new transistors in here. That stuff was all working, but because I had repairs in that board, I figured I'd just go ahead and rebuild it. I didn't really plan on rebuilding this entire receiver, but we'll see. We've done quite a bit so far. But certainly the critical areas like power supply, amplifier boards, relay board, the regulator board, all the places where we found problems initially, I thought it'd be a good idea to rebuild to keep it reliable and to protect it from damaging the new parts. So here's where we're at. After doing work, I always like to double check my work before you go too far. Obviously with capacitors, you want to make sure you got the right ones in the right locations, and you also want to observe the polarity, make sure they're in there correctly. Sometimes the boards are mismarked, and so I like to do a little diagram, take some pictures, make sure all my caps are oriented properly before even powering it up. So I got everything hooked up. I got my voltmeters hooked up to the pin 5 of where the output ICs will be located. And I've got my scope hooked up so we can monitor the audio. I've got a sine wave coming into the auxiliary input, so if I fire it up, you'll see the relays engage. And we're looking at our millivolt output of the pin 5 of the IC chips, slowly going down, but we're at like 20 millivolts roughly. The other one's on its way. So that's a good sign. That means we don't have DC on our output pin 5. As you see, all the lights are working. We're on auxiliary. So now if I crank up the volume and take a look at the scope, you'll see our sine wave there. There's down. Get a little oscillation in the video there, but you get the idea. So we have audio. We got good clean audio. Next step is going to be to put these IC chips in. So these are the ones I received from Pyramid Audio. They replaced the TA-200W IC packs, which let me grab and show you. Okay, so here's the old Kenwood TA-200Ws. We confirmed in a previous part of this video that they're both defective. So we've got the new ones installed on the heat sinks, which are all cleaned up. These are the new IC packs, as you see, TA-200W Plus, pyramidaudio.com. They're not cheap, but they are a good solution for this obsolete part. And here's the other one. So as you see, it only uses 5 pins, 1, 3, 5, 8, and 10. So we've measured those pins. We know we're in good shape. So the next step is going to be to install them. So stay tuned. We'll get that part done, and then we'll do a real audio test with this baby. Okay, here's a quick look at the rebuilt amplifier boards. Prior to installing those IC chips, I thought I'd just show what we did here. So changed out the tantalum input caps with a single polypropylene film cap. Changed out the electrolytics, new transistors all the way around with suitable replacements. I think a new Zener diode, and then checked all the resistors for value. Same thing on the other board here. So now I feel better about putting in those expensive chips. So why don't we get to it? All right, so we're back with the Kenwood KR-9600, and we are ready for its maiden voyage, so to speak. A lot of work to get to this point, but I've got the amplifier IC chips and heat sinks all installed and soldered. I'll give you a little close-up of that. So here they are, and they're all in place. Everything checked out good. Checked all my soldering work, and we're ready to fire this up. I will admit, I already brought it up slowly on a Variac just to make sure there was no smoke or catastrophic failure, but this is going to be its first audio test, so to speak. So I've got it hooked up to my equipment. You're not going to be able to see everything, but we'll do our best. So if we flip it on, you see the dim bulb, still on the dim bulb tester. And got bright, then it dimmed down a little bit. We heard the relay engage, so we know the amplifier circuit's good. If you look over at those 2 meters, that shows you the DC offset, 0.03 volts and 0.02 volts. That's pretty low. I've heard of people with as much as 200, 300 millivolts on these, so not too bad. Let's go ahead, and we have a source going through auxiliary. So let's watch the scope on the right there as we crank it up. And there we go. We have a sine wave. Getting bigger. I've got the meter below it with the red LEDs, 0.05%. That's my distortion. And we are going through the dim bulb tester, so that might affect a little bit. 0.04. Let's see where we're at voltage wise. So the channels are a little not symmetrical. Let's see if the balance. 4.2 volts on one left channel, 4.5 on the other. That's our AC level. And distortion at 0.04%. That's pretty good, I think. We'll double check the specs in the manual, but we're also pretty low on its power. But let's take a listen for sound. That'll get annoying quick, but there you go. We have audio. Let's go to FM. There you go. We've got tunes. We're gonna let it run probably at this state for a little bit, and then we will take it off the dummy load and do a full power test on it.